Okay.
Okay, so I like to write it out this way instead. It just gives me more room. I find a common denominator. So what is my common number that 4 and 8 have? It's an 8. So I change this to an 8 and I change this to an 8. But in math, I can't just change a 4 to an 8. So how do I do that? I multiply it by something. And what do I multiply a 4 by to get it to an 8? I multiply it by 2. Anything I do to the denominator, I do to the numerator. Is that coming back to you?
No. I got lost.
Okay, then watch this. And then how do I change an 8 to an 8 by multiplying? I just multiply it by 1. Anything I do to the denominator, I do to the numerator. Now I have the same denominator, so I can just add the numerators. 6 plus 1 is 7, and then eighths. And then I add this right here. 2 plus 1 is 3. So it's 3 and 7/8. Now for my subtraction, I do the same thing. I write it out, and then what is the common number that 4 and 8? If I'm counting up, it's 8 again. And then in math, I cannot just change a 4 to an 8. So what would I multiply it by? I would multiply it by 2. And anything I do to the denominator, I do to the numerator. 3 times 2 is 6. How do I change my 8 to an 8? I just multiply it by 1. It's the same. So it just stays a 1. Now, instead of adding like I did in this one, I subtract. 6 minus 1 is 5, and then I rewrite the denominator. And then 2 minus 1 is 1. Now, another thing that kids forget is how to change a mixed number to an improper fraction. So I'm going to show you how to do it. So you do denominator times whole number plus numerator over denominator. So my denominator is 10 times 3 plus 8. 10 times 3 is 30 plus 8 is 38 over my denominator of 10. For changing an improper fraction to a mixed number, I'm going to take this 4 and I'm going to put it here, and I'm going to take this 15 and I'm going to put it here, and I'm going to ask myself, how many times does 4 go into 15? It goes in 3 times. 3 times 4 is 12, and then my remainder is 3. This becomes my whole number. This becomes my numerator. And then it's over the same denominator. I know that's confusing. Just watch it a few times and you will get it. And then subtraction. So suppose I have a 3 here and I have, say, a 1 and 4/9 here. This is 0, right? And we know in subtraction, I can't have a 0 and then subtract something from it. So what I have to do is borrow from this whole number, which is a 3. I borrow 1 from it, so this 3 becomes a 2, and then I put the 1 here. But I can't just put a 1 because we're talking about fractions, right? So whatever the denominator is, in this case it's a 9, you put 9/9, which is the same as 1, because 9/9 equals 1. So I borrowed 1 from here and I put it here, but I put it as a fraction. So if this was a 5, it would be 5/5. If this was a 6, it would be 6/6. But since it's a 9, we do 9/9. And now I have the same denominator. So now my last step is just to do my subtraction. 9 minus 4 is 5, and my denominator is 9. And then 2 minus 1 is 1. I know that's confusing. It is very confusing. I'll do another example. If I had 2 and 1/2 minus 1 and 1/4, my first thing I have to do is to find my common denominator, which is 4. I can't just change my 2 to a 4, so I multiply it by 2. Anything I do to the denominator, I do to the numerator, and 2 times 1 is 2. Is this starting to come back to you, Lila?
That one is coming back to me.
Okay. And then 4 times 1, and then I do the same thing here. And then I subtract it. So 2 minus 1 is 1 over 4. And then 2 minus 1 is 1. Now, suppose I had a problem and this was the 1 and this was the 4. Or say it was a 3. But it doesn't matter what the number is. If the numerator is bigger on the bottom, like this, so this is not the same problem. Say the problem was 2 1/4 minus 1 3/4. My numerator here cannot be smaller than this because we cannot say what is 1 minus 3, right? If I have 1 cookie, can I give my friend 3? No. So what we have to do is borrow from this number right here. So this is a 2. I'm going to borrow 1. So the 2 becomes a 1. And then I'm going to take the 1 that I borrowed and I'm going to add it over here. Because my denominator is 4/4, is 4, my 1 is actually going to look like a 4/4. And then I have 1/4 here. So what is 1/4 plus 4/4? 5/4 minus 3/4. And now I have the same denominator and I have a bigger number on top and a smaller number on the bottom. So now I could just do 5 minus 3 is 2/4. Now I know that that's crazy and tricky, but if you watch it a few times, it's going to get easier. Just takes a few times. Now, I see something about this. I'm not done with my problem yet. Do you see why I'm not done with my problem yet?
Because you can simplify it?
Exactly. So I'm going to divide the numerator by 2, and I'm going to...
It's 1/2.
Exactly. Okay. So I'm going to have you try one of these. 1 and 1/5. Or how about if we do 4 and 1/5 minus 1 and 3/5. So the first question we're going to ask is if I have 1 cookie, can I give my friend 3?
No.
No. So I'm going to borrow. Oh, how do I borrow?
You borrow from the 4.
Yeah, and what do I make it into?
A 3.
Yep. And how do I show borrowing? What happened to that 1? What do I do with it?
It turns into a 5.
5/5, right?
Yeah, 5/5.
And then I have to add it to the original 1/5 that was I started with. So what is 1/5 plus 5/5?
6/5.
So we do 6/5 minus 3/5, which is...
Still writing it down. 3/5.
Yep. And then my last step is, what is 3 minus 1? It is 2. Kind of makes sense a little bit now? Okay.
I fixed my camera.
Oh, perfect. Okay, let me make you bigger then.
Well, because I did this.
There we go.
I
Awesome.
did quick. This thing, I pointed up to the sky, and I didn't know that it could go on this.
Oh, okay. All right. Is there anything else before we stop the video that you think you might need help? Okay. How did your review go? Was there anything on there that you thought was a little tricky?
I need to grab it because I thought one of the problems was tricky. No. I had it right here. Well, okay, I have it. I found it. This, like this type of problem, I don't know what it's called.
I
don't.
can't see it. Can you put it on your document camera, or do you not know how to do your document camera?
Yeah, it turned off or something. I didn't know how to put it back on.
Okay, can you hold up the sheet again? I'll take a picture of it and then I'll have it.
I turned it on, I think.
It's okay.
Oh. This problem.
Okay, try to hold it super still. There we go. Okay, so here we go. We have...
It's like, it's with the money in the 25,
Okay, so what is... So there's number of coins, 12. Okay, so you have to find out if there's 12 coins collected and it's $1.20, how many coins is that? Is that correct?
It's, the question is filling in, what is the total of Selma saved in dimes and quarters? And then...
Oh, I see. Sorry, I couldn't read that. Okay, so if you collect 15 dimes, how much is that worth?
If I could.
So if you collect 15 of dimes, a dime is worth 0.10 and a quarter is worth 0.25. So what you're going to do is you're going to multiply 15 by 10. Here are the steps. You're going to just do regular old multi-digit multiplication. So 5 times 0 is 0, 0 times 1 is 0. Put the placeholder, 5 times 1 is 5, and 1 times 1 is 1. So it's the same as a multi-digit. Here is the last step. You count how many spaces the decimal is from right here. So you're going to make a decimal right here.
You're not, by the way, you're not sharing your screen if you were trying to.
Okay, 1, 2 is the number of spots that you had to go over from this spot right here. So then you're going to make a decimal right here and you're going to go over that number of spots. So it's $1.50. Okay, so it's fine because the video's on. But let me try to share it now. Okay, so if they gave you 17 dimes, you would do 17 times 0.10, and then you would do regular old multi-digit multiplication. 0 times 7 is 0, 0 times 1 is 0, and then put your placeholder. 1 times 7 is 7, 1 times 1 is 1, and then it's 170. Now you say how many decimal places is it from right here. So you're going to make a decimal right here and you're going to count in 1, 2. Now you put a decimal right here at the end of your number and you're going to count in 1, 2. And this is where your new decimal is. This is no longer where your decimal is. Then you put a $, $1.70.
That doesn't make any sense.
It does, because this is how you do it. Step 1 is to do regular multi-digit multiplication. Step 2 is count how many decimals it is from the back of the number. And then however many that is, you do the same exact thing to your answer. So it may not make sense to you, but that step 1 is this, step 2 is this, step 3 is this. So if you just remember those 3 steps, I can explain to you what it means, but those are the 3 steps. So what it means is every time you have a number, like say the number 50, there is an imaginary decimal. We just don't write it. When you're dealing with multiplying of decimals, this is how you do it. So when you're multiplying decimals, these decimals do count. And so what we're going to say is how many 1, 2 jumps did it go in? And then we put our imaginary decimal in and we move the decimal that number of places. So
Wait, why are we moving it 2?
because this is 2. If it was 5, then we would move this 5. But we put our imaginary decimal in and then we do 1, 2. We count how many decimals it is from the back of the number to the front of the number where the decimal is. So for 15 times 0.25, we would do the same thing. So we find out what our answer is just by doing regular multi-digit multiplication. So it's 375. And then we put our imaginary decimal right here. We count in 1, 2 until we get to this decimal. And then we put our imaginary decimal at the 375. And then we move 1, 2. $3.75. So I guess to make it simple, a simple explanation is when you're multiplying with decimals, you move decimals in the left or right direction, depending on if you're multiplying or dividing. So for multiplication, you do however many moves you make your decimal jump that many moves. That is how you multiply decimals. Or, yeah. It's that's just the steps that you take. So you're going to take the number of coins that you have times 0.10 or 0.25, or if it was a nickel, then you're going to do 0.05, and if it was a penny, you're going to do 0.01.